Hello, everyone. Can you hear me?
Hi. Yes,
Yes.
we hear.
Oh, it's shiny outside. So let's start. Last week I was on Labor Day vacation, but I managed to working on the O-Node tree implementation, and currently the state of the code is that it's able to insert and is able to merge. I'm still working on. Not sorry. It is able to split and to do point query, and I'm currently working on the merge support, and also trying to catch up with Sam's LBA tree implementation and started reading his code, so we can start reviewing his initial PR, and was also reviewing Chume's extended tree implement design. I will post some comment on his her shared Google Doc sooner. That's me, Chume.
Yeah, so I shared the extend map tree design document, and there are some thinkings on it. And do you want to go through in this meeting, or you guys review first?
I think if it's convenient for you, I think we can have a very short walkthrough on the idea in the design doc. What do you think?
Oh, okay. So after the status update, so let's quickly go through some idea.
Thank you, Brendan.
Hi, everybody. I was working on scrubbing. Like I said in the core meeting, I sent you all my summary of the attempt to use SML, and Sam, thanks for the feedback. I'm back to doing it in both state charts. I'm also, since yesterday night, started to read the Sam's PR, and more or less this is what I managed to do this week. And I pushed a minor fix to SML, which was not merged yet. I don't know if anybody will check it, but it seems pretty dormant now, but I fixed a minor thing there. That's for me.
Right. By some fix to SML, you mean the fix to SML upstream, or some XML to enable us to use SML?
No, just addition to SML upstream.
Oh, okay.
But I see that fixes there are waiting a long time. PRs are waiting there a long time before they're being reviewed. So I'm not sure if it will ever get merged. They're pretty dormant.
Okay.
So yeah.
So the plan still go with the boosted org chart, status chart.
Yes.
Thank you. Sam.
And one more question before
before
I forget. Yeah, sorry, I forgot. I purchased a private license to CLion, to JetBrains CLion, and I was wondering if anyone tried it, made a successful import of the Ceph project into CLion. Do you know?
What is it?
You have. CLion is one of the. Sorry, I can't hear you, Sam.
Is that a C++ IDE?
Yes, one of the major ones, I think, pretty major one, and it was available for purchase in with a large reduction in price now. So I bought a yearly usage license, and I was wondering if anybody.
I haven't heard of it.
Sorry?
Anyone else? I haven't heard of anyone. I'm wondering if anyone else has.
Okay, so if you hear of anybody who made the effort of importing the whole Ceph into it, let me know.
I think someone's managed to get it into Xcode, and I think I remember hearing someone managed to get it into Visual Studio. So it's not, well, people have in the past managed to get it into different IDEs, but it's always a bit of a project.
Yeah, it's a big project. So, and the problem is that you are not in. Almost every IDE now has the option of importing a CMake configuration file, but here you are creating the CMake more or less with the do CMake. So it's another step that you have to configure. It's not a lot of work, but I was wondering if anybody already done it.
Not for me. I haven't tried it out before.
Okay, thanks. That's all for me.
Tim.
All right. So I had a version of the documentation that is sort of similar to what I added to the Google Doc a while back, and to replace cstor.rst, and documented and adjusted all of the interface files so that they match the new format, etc. And so I went ahead and pushed the first PR, which is just the journal and cache extent interface. I'm continuing to work on refining the LBA tree, although I left a link to it if you want to look at the next one. I did pretty up those commits somewhat, so it'll be a little easier. That'll be the next thing I'll push. I likely won't wait until this PR merges. If it's not ready yet, I'll just make it a bigger PR. Either way, up to you guys. Anyway,
I prefer get the smaller pieces merged sooner.
Right, and it encourages me to write unit tests, and that's never a bad thing, right?
Yes, I agree. Shahan.
I was I was developing the Crimson Graceful shutting down, and I pushed the PR this morning, and hope you can review it soon. And that's all for me.
Okay, I'll get it reviewed sooner. Yuxing?
Last week I continued to work on the index deduplication, and I have implemented a special version of lookup for node type 0 and 1, and I feel it is too verbose and complicated, and decide to generalize this logic. The working branch is this one, and this is introducing 3 lookup stages. For example, for node type 0 and 1, it has 3 stages. The first one is to look up the fixed key, and the second is to look up the string key, and if it is matched, then the third stage is to look up the snap and generation. But for node type 2, it only has 2 stages. It just need to look up the string key and the snap and generation. And for node type 3, it only needs to it only has 1 stage, and it's just to look up the snapshot and generation. And secondly, the lookup history of each stage needs to be remembered in order to short circuit the search if the partial key is already matched in the parent lookup. So this is part of the implementation of the string deduplication. So the reason of this is although at block level each node have very different layouts, but I think they can share the similar lookup logic. So I'm trying to work on these templated things to port it into the generic logic into different stages of all kinds of nodes.
So in addition to node compression, you are trying to reduce the runtime overhead when recomparing the compared parts, right? When walking down the tree.
Yeah, that's one part of it to deduplication.
It's not even an optimization. Those bits aren't even necessarily stored in the children nodes. You really have to.
Yeah, it doesn't need to store it. The string part, it doesn't need stored. And for the other parts, if, for example, if the pore is matched in the parent, then even for node 0, the children node doesn't need to look up the pore part if the parent pore is already matched.
Okay. What I'm trying to understand is if your implementation is your implementation already covered by Ceph design doc or not?
It is. It is.
Okay.
Yeah,
okay.
is.
It's just a way of expressing the omit common prefixes.
Because
Yeah.
in some cases, a N0 node could have also N0 children node. So in that case, we have to recompare the compare part, even if we have
that's okay though.
Yeah.
That's okay though. It's that if it has a level 1 subchild, then you don't check the first one, right?
Yes, I thought
You didn't even include it.
optimized out of that kind of comparison. That was my question. Okay. Anyway.
Yeah, that's basically what I'm doing now. I'm trying to work it out.
Okay. Yingxin, and before we move over to the you finish?
Yes.
Okay. Before moving to the extend the tree design doc, anything else? Okay. Make the stage yours.
Okay. Do I need to share my screen? Okay, share.
Yeah, if you think it's more convenient.
We don't see it yet. Okay. No.
Can you see my screen?
I can share. I can see the
Yes,
browser.
I can see it.
Okay, so I open my design document on the Google Doc. For our extend map tree design, so there's 2-layer address translation. So here you can see that in the chart. So there is extend allocation tree. I assume that we can use the LBA tree to serve this allocation tree. It is map the logical address to the physical address, and the root is stored in the superblock of our disk, and each O-node tree, each O-node leaf item will contain extend map tree root. If the extend map tree is bigger than some minimal size we defined, it will stored in the B tree format. So when we look up O-node, we get the O-node extend map tree. Use the object logical offset to search the extend map tree to get the logical address, and then we use that logical address, that logic extend address to search the LB tree to get the physical address. So the precondition is that I assume that extent allocation tree and LBU tree is the same tree, just one tree here. And because we use the segmentation, so the allocator is, I think allocator is very simple. We just allocate from the segment ID offset in sequence. We got the extent we wanted, the extent size we wanted, just sequentially allocated the disk space. And then we map the logical address in the LBU tree. So the LBU tree will serve the allocation tree. They do the mapping, and they have the free address information. So that is the precondition here. And so here is the logical map. So there is object, and we use the offset in this object and the lines to get the logical extent, that is the logical address. And this map is done by the extent map tree. And that logical address to the physical address is mapped by the LBU tree. So that is the two address translation. And yeah, so here is the key and the data stored in the extend map tree leaf node, the format. And so here is the relationship of the logical object logic offset and length and the logical extent offset. The relationship between them when you get offset of object, and it may be not the logical extent offset. There may be inside the logical extent. So here is the relationship between the and the complex part is the clone. When we do some clone, first we have to create a new object. No, not new object. New O node, and they will share the new O node, and the old O node will share the extent map. That means we have to clone the extent map. So when we do the extent tree clone, we can follow these steps. So here is that we copy the root node of the root node to a new root node, and assign this new root node to the new O node, and incremented the reference count for the child node, only for the child node. So only increase reference count for the child node, and before modifying page n so we can see the chart. So when you want to insert some node here, when you modify some new insert some leaf here, and for example, you insert a node H, create a new node, the H. The first you have to clone the child node and reduce the first node reference and set the new node reference to 1, and then set the child node reference count to 2, and then also when you insert each, you have to reduce the old one to reference to 1 and set the new one to a reference count to be 1. So this is the clone tree, the steps of clone tree. This is clone for the extend map tree steps. So you can read it step by step, and it's from the this method is from the reference 5 from this this paper. And
it's the general strategy for rough counted B trees.
Yep. Yeah. So that is when we clone do the clone snapshot, and for the extend map tree, they share at the beginning, at the initial, they share most of the node. When you modify the new node, you just following the steps to create the new node and set the reference count. And this is for the extended map B tree. Another one is for the E extent. So I think we should have to update the P extent, physical extent reference in the extent allocation tree. So
wait, why? What? No, you just allocate a new one, right?
No, for the P extent, they are shared between the two copies. Do we need a reference count to set this P extent?
What
is
would
shared?
You worry about the physical address?
So so one of the things is that the LBA tree, I'm assuming, will handle ref counting, although I may want to rethink that.
Oh, yeah.
Second, though, if you scroll down, you'll notice that you only need to increment the ref count of the first block that's different. So these leaf things that are the things that actually point at the logical extents, you don't need to increment the ref counts, not until you actually propagate the change all the way down. See what I mean? So once you have two leaf nodes pointing at the same extent, yeah, you have to increment the ref count, but not until then.
So you mean that when the two leaf point do the same?
Exactly.
Same physical extent, we have to increase the reference count, right?
That's right. And the transaction manager has an interface for that.
Oh, okay, yeah. That I mentioned here. So when, for example, if there is a file, two file, one is another one's clone copy, and for example, the file full on disk occupied 100 to 103K, 130K, and the new one is the bar file is clone. If they do the append write to the disk to the file, there, for example, write 10K, they will have another physical extent.
Yeah, that's right. So the transaction manager will maintain that.
Yes. So for the first physical extent, the reference count will be 2.
Right.
And
so what you'll do is when you create bars, the second one, right? For each one that you reference again, you'll call increment ref count on that.
Yeah.
And similarly, when you delete one of these things, you'll call decref on all of the relevant things. It'll get rid of the ones that drop to 0 and otherwise, yeah.
Yeah. So I mean the extent allocation tree also has the reference count for the physical extent.
Yep. Checksums as well.
Yeah.
It's gonna have checksums as well.
Oh, okay. So that is.
I just wanted to be clear. The extent tree do not keep the ref count by its own. It would defer this job to LBA tree. That's my understanding.
That's currently what I'm thinking. I don't see this as a fixed point. If someone has a good reason not to do it that way, then we'll talk about it. But that's my current guess. I think everything has to do ref counting more or less the same way, so there's no reason not to do it in the LBA tree.
Sorry, I can't catch up with you. So what's your question, Kefu?
So I realize you're keep mentioning that when we are doing clone, we need to increment the ref count of extent. But to my understanding, currently our design is to defer this job to LBA tree, unless
Well, to be clear,
good. Sorry,
you do actually have to increment the ref count. There's an interface method in Transaction Manager that's incrementing the ref count.
Yeah, but
you don't have to maintain
question,
the ref count. You can trust Transaction Manager to do that, but you do have to make the call. That's all.
Yeah.
I think that's what she's saying, though. Up at the top, she says that the LBA tree handles extent allocation, and if that's what she means, then yeah, that's where we're going.
So Sam, do you mean you agree that extent allocation tree and LBA tree is the same tree?
Well, they're not literally the same tree. It's going to be two trees,
no.
But they live under the LBA manager interface.
Under LBA manager interface.
Which is under the transaction manager. So you just have to call the methods to maintain the ref count. You don't have to actually write it down.
So you think it's two tree, right? But
yeah, well, I've been thinking of extent allocation as the thing that allows me to iterate through a segment and figure out which extents have to be moved. So we have two mappings we need to maintain: one from logical addresses to physical addresses, and one from physical addresses to logical addresses. I'm flexible on this point, but that's what I'm thinking will be the case.
I think extended map tree should expose an interface which allows one to input an address in an object and return the extent.
Yeah,
which is a logical address offered by LBA tree.
So from your point of view, all you have to do is use the interface method that increments the ref count. That's it. It's just a thing you attach to a transaction.
Samuel, can you repeat what mapping in the extent allocation tree?
I think what you're asking is, will the LBA tree maintain a ref count? Right?
No, I mean LBA tree maintain the mapping logical address to the physical address, right?
It also maintains a ref count and it maintains a checksum.
Yes, and what is the mapping in the extend map tree?
In object.
No, extend allocation tree. What mapping in the extend allocation tree? I think the extend allocation tree maintains the logical to physical.
Right. That's the LB. I don't have anything called the extent allocation tree. What I have is, I suppose, the LBA tree, which maps logical addresses to physical addresses. And I think the segment usage tree or something that maps the physical addresses that are still alive back to their logical addresses for garbage collection purposes.
So we needed something, so here, extend the allocation tree for me, just map the logical address to the physical address.
No,
that's the LBA tree. Yeah, okay, that's the LBA tree.
Out here, the extend allocation tree is to address an extended in an object instead of in an extend or the extend on the whole disk or persistent storage.
No, hang on. I think she's trying to figure out whether the LBA tree I'm implementing does what she needs it to do. The extent map is a whole separate thing.
So the LBA tree.
The LBA tree maps logical addresses to physical addresses. It also maintains a ref count and a checksum.
So can we use the LBA tree to allocate the logical address? When I want a logical address space, can I use the LBA tree to do that? Work?
You're not going to use it directly. You're going to make a call in Transaction Manager with a hint for which logical address you want, and then it'll give you the smallest.
I don't know which logical address is not used, but LBA tree will use.
I know that the LBA tree. So there's a call in Transaction Manager. You give it a hint for the LBA for the address you want, and it will give you the minimum address bigger than that is unused and big enough.
Yeah, I give you the size I want, and you give me the exactly.
Right.
So that's the same.
Exactly.
That's the same row. So that is I want extend allocation tree do it. So that is LBA tree.
Yes, and like I said, there's a method for that in Transaction Manager. That's
Yeah. Okay. So I just want the LBA tree give me the address. Logical address. I give you the size I wanted, and you know where the free space, and you give me the logical address.
The free space in the logical extent space, in the logical address space, rather. My assumption is that the hint you're going to pass it is going to be the 32-bit hash for the object. That way,
So,
logical addresses for a particular object will tend to cluster together mostly, and that's it.
yes, so that terminology extend allocation tree is used. I saw in the BRTFS. So I
Right,
think
but that's not. We're not using that here because Btrfs does
yeah.
things that are
So
not the
we
same
just
as what
call
we're
it
doing.
arbitrary. We just call it arbitrary. It's okay.
Yeah, and like we have a different allocation problem we need to solve, so I'm going to use that word somewhere else, and it'll be only sort of related to this. Like, for instance, Btrfs has a non-trivial allocation problem. They have to find space on the disk to put an extent. For us, though, because we're always sequentially writing to a segment, that part's trivial. The hard part is figuring out how to clean a segment. But yeah, for your purposes, what you've been referring to as an extent allocation tree is the LBA tree.
Yeah, it's the arbitrary. Arbitrary is okay.
Tell me, what I want to see in the document is the in-memory layout and on-disk layout of the extended tree. For example, on what circumstances we are going to embed the part of extended tree in the O node, and how is the layout in the O node tree? Oh, sorry, O node underscore T.
O node will store the root logical address of the extended map tree.
Might I suggest a slight modification to that? So it doesn't have to be the case that the root block is the same size as all of the other blocks. So I think what you should do is you should make the root block variably sized, but only up to, let's say, 1K, and then store it in line in the O node.
So you mean if the extended map tree is smaller than 1K, it will store in the O node leaf, right?
I'm saying that if the root, if the tree is ever small enough to fit in the root, then that's all you ever have, right? That's true of every B tree, right? For any B tree implementation, if the entire key space can fit in one node, that will happen. It will be in the root. You won't have any other nodes, right?
Mm-hmm.
Yes, I think
so. My suggestion is that you choose to make your root node variably sized, but only up to a certain size, let's say 1K, and just always store it in line in the O node. That way, in the pretty common case, like for instance, every RGW object, there will only be one little bitty extent in the O node, or one little bitty byte range in the O node that just tells you where to find the data. That's it. No actual tree, because the tree is one block large and it's tiny. But in the case that the extent map is actually complicated, like for instance, you're dealing with an RBD image with a lot of mutations and clones, and it's highly fragmented, then it would naturally balloon out to multiple nodes. Do you see what I mean?
Probably in that case, we should not embed the O node extended tree in the O node.
But again, you're not. You're just embedding the root node.
Yes, that's the case.
And it's fixed size, or it's bounded size. It's only up to whatever you chose as the biggest possible size. It's still worth it, right? Like if you can make the O node a little bit bigger to cut down the height of the tree by 1, worth it.
You could save a RAID or
yeah, exactly. It may in some cases reduce the height of the tree by 1, which is worth it. And again, you choose the size based on how big you want the O node to get. It's not like you have to make the O node big. I'm just suggesting this is one way to look at it. It naturally gets you that flexibility where for simple cases, it's just in the O node and you're done. And for complicated cases, it naturally extends out.
Yes, I think that's the missing part in the O node extended map tree in design doc.
So, any question?
I think this looks about right. Like the way you're handling clones is pretty much exactly what I expected. That looks fine. This looks good.
Fine by me. I think we need to just to to document or lay out some consideration regarding to the embedded unembedded ONode tree. Sorry, the extended map tree on the different use cases. That would be ideal.
So what do you mean the different use cases? Inline or tree?
I think Sam just mentioned that in the case of RJW, it is very likely to have a very small small extended map tree. In that case, it would be a big win if we can embed the ONode extended map tree in ONode. That would save us a lot.
I'm saying that operation is free. All you have to do is do two things: limit the size of the root, and always place the root in the ONode. That's it. You don't have to do anything special. Right?
I think so.
Yeah. So I don't know that I'd worry too much about the inlining part. That can be a thing we worry about in maybe version 3 of the doc. I think the next part is indeed to write down the on-disk structure for the interior and leaf nodes. And feel free to have a look at the way I did the LBA tree. I'm not, to be perfectly honest, I'm not sure that the way in which I did the binary operations is entirely portable. But if you think that design works, feel free to borrow it.
Good to conclude the meeting. Any questions or comments? Okay, thank you guys, and talk to you later next week.
Later.
A good one.
See you later. Bye.
See you.
Bye. Bye.
Bye.